Hi, folks. We're going to take a look at number 7 from the Unit 7 review assignment. So here it tells us that a farmer has $2,400 to spend on 2 rectangular pastures, as shown, so as in this diagram, and they tell us that the fence costs $6.25 per meter. Okay, and they want to know what is the largest total area that a farmer can have fenced for that price. All right. So what I'm trying to maximize, so the first thing I notice is the word largest, meaning I'm looking for a maximum value. So it's an optimization question. In other words, I'll be working with the vertex. Presumably, I'll be working with a quadratic function. So here the area is given by length times width. Okay, so we'll call this the length, and we'll call this the width. And as we often have, is this function here is a function not of one variable but two variables. So hopefully I'll be able to do a substitution so I can write the right-hand side in terms of one variable alone. All right, this is where things are a little different because normally we're given the perimeter, so the amount of fencing that's going to be used to surround these pastures. But here they tell me the amount of money that I have to spend. So this is not, the perimeter, the $2,400, but it tells us how much we can spend on fencing. So if I can spend $2,400 and each meter of fence costs $6.25, I can just divide these two numbers to determine the length of fencing that I have at my disposal. Okay, so the fencing, or at least the total fencing, is given by the amount that I can spend on the fencing in all, divided by how much it costs me per meter, $6.25. So this is where we'll get our calculator, and 2,400 divided by 6.25 is equal to 384. So this is actually the amount of fencing that I have available to me. All right. And I know that I can calculate how much of it I need to surround these two pastures, because I need 2 lengths on either side and I need 3 widths. Okay, so don't forget that you need that fencing in between to create the 2 pastures. Okay, so we have 2L plus 3W is going to be equal to the total amount of fencing, which is 384. Okay, and this is the equation I'm going to use to do my substitution. So the question is, should I isolate L or should I isolate W? Now, often it doesn't make a difference. Here, I think it does make a difference, because I would much rather divide something by 2 than have to divide it by 3. Okay, because here I know I'm always going to end up with a nice decimal. When I divide by 3, I'm going to be stuck having to either work in fractions or estimate with a non-finite decimal. All right, so I'm going to choose to isolate L here. So L is 384 minus 3W divided by 2. And here, 384, so I might as well use my calculator since I have it, divided by 2. So that's 192. And then 3 divided by 2 is minus 1.5W. All right. So now I can do my substitution. Wherever I see L, I'm going to substitute it with this expression here. So the function for area is given by 192 minus 1.5 W times W. All right, and now I have a function in terms of one variable, and not only is a function in terms of one variable, it's a quadratic function. Okay, so let's multiply this out. So we have negative 1.5 W squared. So notice how I'm choosing to put this one first. Okay, and then of course plus 192 W. All right, and let's take a look at what they're looking for. They want the largest total area, and so that's what I'm going to find. So there's a couple of ways I can do this. So I can complete the square. I could use the fact that I have this in factored form, find the zeros, and then take the average and then plug it back in to find my maximum area. Or I can use that new formula that we learned, that the h value of the vertex is given by negative b over 2a. Okay, so I'm going to do it in 2 ways. Let's do it the quick way. So if I do the quick way, I know that the h value of the vertex is given by negative b over 2a, so negative 192 divided by 2 times a, so 2 times negative 1.5. And right off the bat, I can easily calculate this. Okay, so we've got negative 192 divided by, open up a bracket, 2 times negative 1.5, and that gives me 64. Okay, but of course 64 is not what I'm looking for. Okay, so if this is freezing, I apologize. Program's kind of crappy these days. What I'm looking for is the maximum area. So I'm actually looking for the k value of the vertex, the y value of the vertex. So I would just input this into the equation. So negative 1.5 times 64 squared plus 192 times 64. And let's calculate that. So we've got 64 squared, okay, times negative 1.5, okay, and then plus 192 times 64, and we've got 6144, and since it's area, it's meters squared. Okay, so this would be the quickest way of solving the problem, I think, or, and in fact, it won't be that much less quick here, is to complete the square. So here, if I start by factoring out the negative 1.5, okay, this is going to be a subtraction since it's a positive divided by a negative. So what do we have? We have 192 divided by negative 1.5, okay, negative 128, okay. And now we go about completing the square in the bracket. So here, w squared minus 2 times 64w plus 64 squared minus 64 squared. Okay. The first three terms give me my perfect square, w minus 64 squared. And I'm not going to bother calculating this. I'm going to let the calculator do the work for me. So negative 1.5 times the first expression, which is my perfect square. Okay, and then this is going to be, well, it's going to be a positive number since it's a negative times a negative. Okay, and let's calculate that here. We've got 1.5 times 64 squared is 6144, exactly what I expected to get. Okay, so here the maximum area is 6,144 meters squared. So let's do a quick recap. So this had a little bit of a twist because they didn't give us the perimeter directly. We had to calculate it first. Okay, but once we had the full perimeter, we were able to use that to isolate one of the variables so I could substitute it into my area function to give me a function in one variable alone. And then from there, once I had it in standard form, I had a couple of options. I could have used negative b over 2a to determine the x value of the vertex and then plug it in to find the y value of the vertex. Or my other option was to complete the square and find my answer in vertex form. Okay, that's it for this one.